Hello everyone and welcome to the iHub Summit 3 webinar series. For those of you who don't already know me, my name is Marie Karekla, AERA's Engagement and Program Coordinator. Today's session on Data Clearinghouse is the second of the 3 webinar series that are taking place this week. Just before we get underway, just a reminder, if you do have any questions throughout the webinar, please type them into the Q&A function that's located just at the bottom of your screen, and we'll allow for some time at the end of the formal presentation to go through as many questions as possible in the time permitting. So I'd now like to pass things over to AERA's Chief Executive Officer and Chair of the Innovation Hub for Affordable Heating and Cooling, Tony Gleeson. Thank you, Tony.
Thank you, Marie, and welcome everyone to today's session. Before we begin with, I'd also always think it's worthwhile to recognise that we do gather from many parts of Australia today. And as part of the Innovation Hub, I want to acknowledge the traditional custodians of the various lands on which we meet today, and the Aboriginal and the Torres Strait Island people participating in this event. I want to pay our respects to the elders present, past and emerging, and recognise and celebrate the diversities of the Aboriginal peoples. I'd also like to recognise here today the contribution that ARENA has played to the Innovation Hub. And in that, the Australian Renewable Energy Agency has provided funding for this program and has been supporting us throughout the last 2 years. And it's probably worthwhile to also recognise that we're effectively 2/3 of the way through this overarching project. We've had many partners that have contributed to this. As part of this, in particular today, the Data Clearinghouse, our major partners are CSIRO, the New South Wales Government, particularly education, schools, infrastructure, switch automation, and in particular, AERA as being a participant and building Evolved. Again, as I mentioned, we're about 2/3 away through this. We've really started to get some output and some real value from the project. Of course, more information about other projects and more information about the iHub itself can be found at ihub.org.au. We'll be continuing to providing updates regularly. After this session, there will also be a session tomorrow, and there'll also be a session around September where we'll hopefully can get together face to face and share some of these experiences together later on in the year. But enough of me for now. I want to thank the people involved today, and in particular, I'd like to hand over to Professor Stephen White to continue this session. So enjoy today, and Stephen, over to you.
Yeah, so we've got an excellent set of presentations today. Parag Shinde from Property New South Wales is a new project that has just got started at the beginning of this year, and also Carl Agar from AG Coombs talking about brick and VBIS. That's another project that has just got started in the last couple of months. So I'll just run through some sort of introductory comments, bit of a refresher on the Data Clearinghouse and some of the latest developments, and then we'll go into the meat of the session with Parag and Carl. We'll try and make as much time as possible for Q&A. So just as a refresher, well, what is the Data Clearinghouse? Well, we see the Data Clearinghouse as a collaboration platform for innovators in software as a service for building services applications. The Data Clearinghouse there is providing an infrastructure component that enables data from disparate locations to be collected in the one place. That's data from the cloud, such as weather data, the Bureau of Meteorology, the National Electricity Market, etc., along with emerging Internet of Things sensors and devices, and federating that with data from the building management systems. So the key bit here is getting the data, federating it, that's bringing it together, connecting it so that it snaps together nicely into interoperable, standardized and structured formats. And then, you know, that unlocks a sandpit, if you like, for innovators to play and to deliver competitive data-driven services. Why would we do this? Well, I guess from a building owner's perspective, you know, I sort of look the building owners in the eye and sort of say, well, you know, can we get some data? And the look of fear on the face of the average property owner there, because they realise that it's actually, they find it difficult to actually access and share that data in a controlled fashion. So I see it as providing building owners with functional ownership of their data. And for the software providers, you know, it's a platform where buildings can join, and so there is a growing portfolio of customers that can use their services. So, you know, why would we do this? Well, you know, I bumped into this over the last little while since last sharing, which was the Open Data Institute in the UK with their concept of data institutions. And, you know, what we want to do is unlock value from data, but there are two big barriers to that happening. One is people who have the data, who want to hoard the data, and the other is people who have the data who are just too afraid to even think about sharing it and unlocking value. So in terms of what the platform does, it is linking data. So as I mentioned, all those disparate data sources and enabling them to snap together in one location so they can be accessed. It's providing them in open data structures and using standards so that people can access quickly and easily that data. And then, you know, you could almost envisage iHub and all that we're doing with the support of ARENA here as providing a sandpit where innovators can develop applications. But it is right to be worried that data would be allowed out in an uncontrolled fashion. And so any organization that fears the sharing of data would want to know that there is restricted access. And so managing controls over data is key. And if they can't do that themselves, then clearly they'd be looking to outsource in some form or other the ability to share data in a controlled fashion. And combining all those things, we look to this idea of a data institution as a place that can steward the data in a way that addresses the considerations of the data fearers and the data hoarders, creates active use in order to unlock value. And so the iHub Data Clearinghouse activity is sort of in the early steps, I guess, of ideally becoming some kind of data institution that can unlock value for everyone in the ecosystem. And key to that, of course, is supporting standardization. And it's not just sort of haystack naming conventions for individual data points, but also the idea of a building model where there are relationships or metadata between the data points, which actually gives some contextual information that enables data streams to be understood and have meaning. Well, why would we go about doing that? It's so that we can actually create some kind of environment that, at least philosophically, is something like our mobile phone and the apps that sit on the mobile phone. The scalability that we get from mobile phones and apps there is the ability for people to self-serve, that is, download an app and activate an app at their discretion without intervention. And so the more we can standardize our data streams, the more we can head towards that ideal situation. And that way, our software services achieve scalability and substantially reduced cost over current. But putting it all in a kind of a one location also plays an important part of driving competition and driving innovation in our industry. So we see that this activity is providing substantial value from standardization and ideally ending up with a data institution that can support an ecosystem of innovation. So where are we up to? The original 3 projects that were mentioned at the beginning with CSIRO, DCH1, DCH2 was with switch automation, and DCH6 with schools infrastructure New South Wales has now got another 3 projects and additional project partners and collaborators there. Each of the partners brings buildings which go onto the platform, and the data from those buildings can be accessed in a managed way, and the projects bring new applications or services to reside on the platform. And in that way, we get that sort of concept of the data clearinghouse as the infrastructure with an ever increasing number of apps that sit upon it. So we've got something like 25 buildings there that are contracted to be on the platform. The original buildings that CSIRO put on there have expanded because CSIRO's facility management have loved what they've seen, and the system is growing very nicely. So in today's webinar there, we've got 2 new projects coming on. So Property New South Wales, Parag will talk to that project and some of the sort of philosophy behind where Property New South Wales are coming from. That's DCH4 and DCH7. So Carl Agar there will be talking about the VBIS schema and the links to BRIC there, and some of the first instantiations of some of these schemas in real software that can use it. So that's just a quick introduction and overview, and so now I will stop sharing and I will introduce Parag Shinde from Property New South Wales. So Parag is the Group Energy and Sustainability Manager at Property New South Wales. He's got more than 15 years experience with government, listed property companies, construction contracting companies and consulting businesses across the built environment sustainability spectrum. And as you'll see in his presentation, under his guidance, Property New South Wales has achieved huge uplift in their energy performance. So without further ado, then Parag, I'll hand over to you.
Thanks everyone for joining us today. And today what I'm going to present is on our asset management and asset owners perspective on the IoT strategy and smart buildings, as well as our partnership with DCH, what Property New South Wales is mandated to do as a business, what is our 3-step strategy. Currently we are focusing on stage 1. What are the components we are collaborating with DCH and CSIRO on, and what the overall outcome looks like at the end of full implementation. So just to start with, what does Property New South Wales do? What are our strategic business and project objectives? So we are set up under the Act of Parliament of New South Wales. We focus on delivering management of large and complex real estate projects, transactions, workplace strategies, design and delivery, and manage state significant property portfolio. So our primary focus is on the office side of things. We own about 200 owned properties and 500 leased assets, which a lot of them have green leases. Property New South Wales mandate as a service delivery is to deliver safe, comfortable, quality, and fit for purpose office accommodation for all New South Wales agencies. There's about 140 of them. We optimize asset utilization, management cost, improve occupant comfort, and deliver staff productivity and environmental performance. We also have to comply with the legislations and policies that are listed below. Like primarily, my team is focused on the Government Resource Efficiency Policy 2019 and the state's Net Zero Plan 2030. But all the other property legislations, health and safety ones are also a requirement. Why did we decide on going down the IoT path? What were the challenges we have with our portfolio and the opportunities we saw? On the right-hand side of this slide, you can see the current locations of the 11 properties that we are implementing IoT smart building systems at, out of which 5 of them are partnered with the DCH4 project and CSIRO. We have very unique challenges being a government property operator. Most of our assets are spread across the regional and far regional locations in New South Wales. Our asset size are not as large as the metro buildings. They mainly consist of assets which are 2 stories to 7 stories high. And they are B and C grade assets most of the time. We do not have any on-site facility management staff, so most of it is remotely managed. Our asset valuation is one of the factors we have to consider. So we have an asset in Broken Hill, Tweed Head, and Albury. For the same side asset in Sydney Metro, the valuation would be 10 to 50 times higher. The cohort that we have who will purchase or occupy those assets is very limited as well. So that comes into the aspect of marketability and appeal. Tenant complaints and verification and rapid response. So you can imagine, like, if we had a complaint from Broken Hill, to send some technician from Sydney to fix it or to even verify it is a genuine complaint, not a perception that the tenant has, is difficult without oversight. Then we have equipment repair and maintenance costs that just pile up because of the regional spread. Again, sending skilled technicians from Sydney is actually the bigger cost than fixing issues. We have lack of skilled contractors in the regional locations. As I said, our sites are predominantly in the 2-story to 5-story range, and some of them are smaller. It's very hard to justify a BMS, full-blown BMS investment. We also need an open source adaptive and agile building system. So if we have 200 properties and everybody does ad hoc technologies and control implementation, it's pretty hard at a portfolio level in our head office to gauge what's happening. We're also looking for a plug-and-play off-the-shelf solution, which eventually in 10 years' time, anybody who has building technical expertise can integrate and manage. So those are some of the challenges and opportunities we focused on before we started on this journey. Let's talk about the 3-stage strategy we have on the IoT platforms. So today we'll be focusing on stage 1. Stage 1 is pretty much data capture. So connect the assets, read the data, analyze the data, optimize the building and fine-tune it, and economize faults and maintenance regimes. So that's what we are going to focus on this year and next year. Stage 2, after we have enough learning from that, we're going to focus on collecting and controlling also. So we'll write data back to BMSs and other control systems once we have enough confidence that the information we are reading is actually accurate, and we can make decisions based on that. The third stage of that plan is to actually incorporate occupant feedback and eventually live occupant feedback. So these stage 2 and stage 3 layers are inputs to our decision making. And once we analyze the occupant feedback and what's happening on site, we will draw correlation and make assessments and maybe have a self-sustaining system that makes decisions and adjustments on its own. So our interest at this stage from stage 1 perspective on the smart building platform is for these reasons. We have about 8 different platforms for utility management, building management, bill validation, and all sorts of things with different logins, and they don't talk to each other. So we're looking for a single source of truth for all site-specific information, one platform to manage all building systems and avoid duplication. Monitor and optimize building performance, support remote fault detection and analysis, a system that independently verifies. So that is very important. You don't want to rely on the incumbent contractor information or the tenant information. You want a source of information that is independent of them. And once it verifies and assesses, it automatically raises work orders. Once the work is complete, then we actually have an avenue to check if the work was done to the standard. What will this result in? So this is our expectation. It will result in operations and maintenance cost reduction, extend equipment life, avoiding faults, utility cost reduction. This is one of the major areas of focus, false positive detection. Because we have 200 assets, there's a lot of like hearsay information and people just make assumption based on, I don't feel too good or whatever. So we want to eliminate that based on evidence and data. And also reduction. So because our portfolio is aged, our average portfolio age is 50 years and more. We have 200-year-old assets as well. There's a lot of repairs and maintenance costs that pile up. So with these systems, we want to optimize that and reduce the cost. The graphic on the right, so that's sort of the concept. So you control the facilities and space, you connect the data from various sources, and it should be mobile, anywhere, anytime, accessible. You collaborate with the human interface. It might be the occupant, the contractors, and all sorts of people, get them together, and based on factual evidence-based data, you work with them to deliver the outcomes to conserve energy, cost, etc. So this gives you a bit more detail on what we are capturing from a data perspective in stage one. So building information, as the spatial information and all sorts of building information that's in the property database. Utility meter data, so electricity, gas, and water, they're all 30-minute interval smart meters. Solar system data, so that will cover total generation, on-site usage, and export. BMS data, where BMS is available on the 11 sites, including zone data, so thermal comfort, lighting, occupancy, and in some cases, people counting. We're also focusing on into environment quality data, so aligning with the neighbors' IE and Green Star rating tools, live capture of carbon dioxide, particulates, and TVOC. In the graphics on the right, it shows you a schematic of the journey. So first you acquire data. Data can be crap or good, but you transition that working with standards and partners like CSIRO into information. Information is what you can analyze and derive insights from for decision making and then take action. So it just covers all these different types of data sets from security, fire, etc. Currently, the industry works on completely different platforms and logics. So how do you unify all that data to derive insights and overlay them to make decisions is an important factor. This slide shows you a schematic of our data integration architecture for the current project. So you have the on-site, so you have the properties, you have the sensors, BMS, and controllers. So the edge platform is the connecting system. You can actually build, say, management dashboards, information sets, and performance metrics overlay on that. The edge platform then forwards data to DCH and the Intelli command. So Intelli command is where all the analytics, rules engine, fault detection, etc., and also integration with the Corrigo work order interface is set up. Corrigo is our vendor management system, so that's where we have all the vendor inductions as well as work order, purchase order management. And then you have both those data sets converging. So the vendors will complete the task, they'll log into the system and say, we have closed the job. But from the Intelli command inputs and analysis, we'll check if whatever they have done is to a standard scope and that has delivered actual outcomes. And then the final data set feeds into the broader JLL platform, property platform for asset performance. So Jones Lang LaSalle currently is our service provider on the contract. So that will give an oversights to the asset management, fund management teams for better decision making. This is a bit more detail on how the data flow hierarchy works. So you have all these various sensors on site, which will then connect to wireless and wired data aggregation devices. And these devices then feed that data into our current service provider cloud and third-party cloud services like the DCH and anybody else. So why did we decide to collaborate with DCH and CSIRO on this project? We see very unique benefits of our collaboration with DCH. So first off, it's the data democratization. So we are aligned with the vision that DCH has to bring along all building industry data on a single platform, thousands and hundreds of buildings together, because with more data, we can analyze more and derive better insights. Data standardization. So there's, as I said, security systems and lift systems and HVAC systems all work on different standards. We want to standardize the data and information and tagging of that data. We also want DCH to support the quality, privacy, and audit layer, so reliability and accuracy of that data, so people don't question it. Data discovery, which is a difficult part. So plug and play, we keep talking about it, but it's not that easy. So it should work as seamlessly as your home Bluetooth or Wi-Fi connectivity and device and data discovery. Research and reuse. So this is an important aspect. So partnering with CSIRO, who's doing a lot of research in this space, the more data they acquire, they can derive better insights, better use cases, and create a data marketplace for other participants to use. It's a centralized source of all data for buildings. So avoid duplication. There's anyone who's worked in the building industry knows there's so much duplication. The same data, even within a unique organization, is stored at 100 different locations and used for 100 different reasons without different business units knowing about it. So we want to reduce, and that obviously results in cost. So we want to reduce that and improve governance and create a data ecosystem as the last step. So it's almost like comparable to an iOS or App Store, where you have all the data available, open source, and then app developers come in and build systems and processes on top of it. So who are our target market participants? Application developers, they'll have low cost of entry for startups. IoT hardware vendors, open source industry development enablement. Building owners, reduce upfront cost and ongoing cost, have unlimited platform options. And we want to transition to a subscription-based service like Netflix, where if you don't like the service, you test it out and then you walk off and try something else. And it should be that easy. System integrators, increase participation and low entry hurdles for them. Standardization bodies. So Carl will dwell into that a bit more in detail later on. But yeah, we want data standardization across the industry. IoT service providers. So this is a full suite service provider who can bring in the data, set up systems, and deliver insights. Also building services contractors who will be supported in their actions and delivery of service based on the platform outcomes. So that sort of covers off stage one. And then what is beyond stage one? So what we want to focus on is an occupant-centric building operation with live feedback. So this is just an example of thermal comfort. So you operate the HVAC system. It gives feedback to the tenant in terms of current temperature in their zone. The tenant then decides and the occupant decide if they're comfortable. They use an app to provide feedback, good, bad, neutral, or whatever, or specific feedback. That goes back to the algorithm engine, and it makes decision based on that and changes how the HVAC operates, and it keeps happening constantly. So that's a system-based approach. We are also looking at implementing feedback from platforms like TeamGauge on a monthly basis, where there's just cursors which people can push up and down and let us know if green means good, orange is go for improvement, red's high alert. And then also when people log in, because a lot of occupant complaints and issues arise from perceptions and how they feel rather than facts and figures. So when they log into their computer on their intranet web page, first thing they'll see is what's the current zone temperature and some other details as we progress. And if they're unhappy with that, they can log in a complaint with the details provided. So that's active user feedback and input into the system. So now let's come to the project we are partnering with DCH on. So out of the 11 properties, as I said, we have shortlisted 5 for many reasons. They're in different climate zones. As you can see from the pictures, this is a 200-year-old asset heritage. Some are multi-story, single-story buildings. And we have a lot of unique issues with these assets. But they're also having, so Lithgow, for example, has a battery project that's going to be implemented. It has solar. Some of them have solar. We have IoT across the board. So it's a mix and match of technologies that we are going to test in partnership with CSIRO to see what we can deliver in insights. Our current portfolio performance. So this is another challenge. So we are the only whole building rated portfolio in Australia that's publicly listed. This current SPI index, our energy performance was 4.7 star without green power, so 8th in Australia, and 4.9 for water, first in Australia. We have just recently achieved the Green Star 5-star certification performance and carbon neutral certification across 22 assets that are 1,000 square meter and above. So why I'm discussing this is it is getting extremely difficult for us to progress any further from a ratings perspective, considering all the stuff I mentioned about the age, location, all sorts of things of our portfolio. So we are trying to see what nuances and new things we can bring to the table. IoT is one of the important projects we are working on to see if remote management, insights, and information can help us drive better performance, furthering these targets for our portfolio. And finally, just a slide on where we started and what are the things that people need to consider if they want to develop an IoT strategy which is suitable to their business and portfolio. So first up, ask why, what, how, who, and when questions. Then take some time to develop a use case based on your unique challenges and opportunities. Also think of what the value proposition is and what value creation you offer from the project and the effort you put in. Define project outcomes clearly, so financial, environmental, and social. Identify investment required and cost benefits. Establish a good project team. It is very important. This is a unique subject matter expertise area. So you need to have the right people who understand strategic, tactical, and implementation aspects of this project. Have a very detailed scope. Because it's a new area of work, we found we almost spent like 18 months going through an EOI tender process and discussions with CSIRO. So give it time. Look at every aspect, what can go wrong, what you need to cover off, because even the industry is not up to speed across this space. Outline clear roles and responsibilities. That's a common sense thing. Establish project and financial milestones. So we have a clear arrangement with CSIRO and ERA on the current DCH project and the milestones. Identify relevant research technology. So after putting all that effort upfront, just don't do a standalone project. Also review which research, technology, asset, government, and industry stakeholders you can talk to or share information or partner with to deliver better outcomes and applicability across the industry. Establish project KPI and reporting requirements, and then finally develop some case studies and knowledge sharing framework to benefit the broader industry. So that's it from me, and thank you for your patience.
All right, so I'll hand over now to Carl. So Carl Agar is a senior consultant with AG Coombs Advisory with more than 35 years industry experience, including more than 10 years in the IT industry implementing service and asset management systems. So he provides advice to clients on asset management, commissioning, building, tuning, and service management and the adoption of leading edge technologies. I'm sure you will have come across Carl before in his work where he's been instrumental in the early application of BIM in our industry. So again, another excellent speaker. So handing over to you, Carl.
Okay, so I'm going to cover two subjects. One's VBIS as a standard, and then move on to BRIC as their integral. And then we can have some Q&A generally. So just the inception of VBIS, it's actually derived from the BIM-MEPOS standard. BIM-MEPOS started an initiative to set up a standard for naming of equipment, and this standard is a derivation of the same structure, if you like, of information. And some core principles when we look into that was to remove equipment use from the classification, because people would often describe an asset as a chill water pump or a hot water pump, etc. But when you're looking at it from an FM point of view, it's a pump. What it's being used for is not relevant. And we set a couple of objectives. One is to have an open public domain standard for asset information. So it's an industry standard. It's not owned by anybody. It's owned by us collectively. It's not software. It's system agnostic. So it was designed to work with existing applications, existing database, as well as new off the shelf. And it provides a means to normalise unstructured asset data. The most common problem you have when you're looking at databases is people have just categorised it different ways in different databases. You don't really want to go and disturb that and try and restructure them all the same way. You need some way that you can normalise the data. And we can provide some facilities comparison of records in these different databases. So developing a tagging system, it's somewhat of a Rosetta Stone. So we're looking at a consistent way to search across databases and a consistent way to standardise the asset structure. So that if you had a structure of pumps, for example, that you've standardised how you categorise them. We want to be able to cross-rest across existing categorisation systems such as Uniclass and Omniclass. And also, and I'll get to this when we talk about the brick, is how you then relate that to define standards such as hashtag and so on. Linking BIM model objects into O&M document repositories, it's an ongoing issue in that the model is one thing. All of the information that gets handed over at the end of a project in forms of O&M manuals, and even going back to specifications, briefs, fire engineering reports, etc., that all resides somewhere else. It doesn't reside in the model. And how do you make the two talk and link? You need to be compliant with the ISO standards. So this is compliant with ISO 26005 and ISO 22274. Those standards, as they often do in standards, don't actually define something in absolute terms. They really define principles on which you should work, and we certainly work to those. So it's a 4-level classification structure, and I'll show you where Uniclass and Omniclass fall down in that area. But in principle, the first level is the discipline: mechanical, hydraulics, fire, etc. The second level is a product, for example, a pump, and then you've got 2 further levels to categorise that. Most products go down to a level 3. Some go beyond level 3 to a 4th level. So if you take security as example, level 1 security, level 2 CCTV as a set of products, level 3 is a camera, and then it's a PTZ pan tilt zoom. And you can see how the code is built up. The coding was built in English and to be readable rather than numeric. I know why they've gone down the numeric path, and particularly in Europe where you've got language issues, but it's not very readable. And here's the second example: mechanical level 1, 2 is a chiller, 3 is a water-cooled chiller, and 4 is a centrifugal chiller. And anybody who's been dealing with chillers would know, for example, that magnetic bearing chillers are quite different from centrifugal in terms of their maintenance regimes and issues and so on. And again, you can see how the code's structured: ME for mechanical, CHR for chiller, WC for water-cooled, and CE for centrifugal. And so this is just an example of one of the tables where you can see how the codes are built. So you've got chillers, you've got air-cooled, packaged air-cooled, adiabatic, water-cooled, absorption, and I see absorption's duplicated there, just ignore that. And then within those, you type within air-cooled, then you can have centrifugal magnetic bearing, screw, scroll, heat pump, reciprocating. And this becomes very important when you're looking at this from an FM point of view and you're trying to find particular types of equipment. If you're having issues with that equipment, where do I find other types of this, or where do I have it in my portfolio? And then if we're dealing with the iHub, that allows us to potentially go in and find all instances of that chiller and look at the right across multiple portfolios, what sort of experience people are having with that particular device. So why didn't we use Uniclass and Omniclass? And the answer to that is the gaps in the structure. It just doesn't provide the granularity you need. So if I take this example with a mechanical pump, a centrifugal and a long couple pump, and I've got my code, I've also got a set of codes that I can wildcard. So if when I'm surveying the asset, I don't know that detail, at least someone can say, well, I know it's a pump, and we can send someone back to say, well, let's find out what the balance of the code is. In this case, we compare it to Omniclass and Uniclass, and you can see that, sorry, let's go back there for a sec. The problem with Uniclass and Omniclass is that in many ways, they're only a 2-level structure. The first, just go up here for a sec. The first 4 levels or 3 levels in the case of Omniclass are effectively the same categories. So it actually is only giving you 99 categories beyond that to search. And the other problem is the gaps. And VBIS, for example, we do collaborate with Uniclass in a lot of ways, and they recognise that whilst their system is very good for construction, it's just missing that granularity. And because of the way they've structured their scheme, they really can't do much about it. They're stuck. So they promote us as a way to go beyond that. So applying the tagging system, we put a prefix, which is the discipline. Now, the discipline codes are the same codes that BIMEPOS define and the ones that are pretty well standard across Australia. So we've stuck with those as convention. And then there's an equipment code, which is doesn't have to be unique, but we do make it unique so that we can use the pump designations and the other classifications of pumps in other disciplines, such as hydraulics. So then we can take it down to the centrifugal pump and then the centrifugal end suction pump. And then the codes are designed for searching for wildcarding from both ends. So if I wanted to find centrifugal end suction pumps and mechanical, then I can put a wildcard on that and just search for mechanical or hydraulic use. Or if I wildcard the front part, then I can find all instances of that pump. And if I wildcard either end, I can find all centrifugal pumps, regardless of whether it's fire, hydraulics, mechanical, etc. And from an FM point of view, it depends what I'm looking for and what I'm trying to achieve. Now, getting onto brick. So we came across brick in 2009, and they were setting up an ontology to link the haystack names and create a system where you could actually describe the entire building. And the obvious thing that from our point of view was that when they got to the equipment level in their ontology, they pretty well left it to the user to define. And we're still unravelling that to some extent, because people went off, and it's the same problem we have in databases, where everybody calls a pump, or there's a standing joke in AG Coombs service of 22 ways to describe R22. And this is exactly the same problem we have here. And so that's when we realised that we could provide that level of the standard to Brick, and Brick also realised the same thing. We had something excellent to offer to really standardise their ontology from the equipment level down. So that's where we provide this component, where we can put those codes in and categorise at that level. So just to formalise that, there is a memorandum of understanding between Brick and VBIS to collaborate and integrate the developments. And then Brick has been picked up by iHub, so that it sort of automatically picks up VBIS. And there's a project rolling to go roll that out. And that collaboration brings together both of our complementary developments in this area. And they have an extensive dictionary of IO points and setting up the relationship below those points. VBIS goes way beyond HVAC. It's got some 23 categories, so it's describing everything. As I said, we captured assets that are not covered by Brick, but perhaps they will be covered in time. The other thing about Brick is that Brick's been adopted by the Google Digital Building Project. So Google have adopted Brick as a way to really start to describe the entire asset, be up above the equipment level and across portfolios. So combined, you end up with a comprehensive data model definition. So it sort of then supports deploying analytics, energy efficient measures, automation, life cycle planning, maintenance planning, performance benchmarking, and linking asset data from disparate locations and disparate databases. It's quite an issue that everybody talks about big data, but having been confronted with big data, how do you actually normalise it and analyse it and start to get some meaningful results? And to do that, you need a standard way of categorising and categorising assets, and also be able to compare disparate databases. people aren't going to go and restructure a database to a different standard because it's a good idea. The idea is BRIC is that you can add a field to a data record, and you can look at it a totally different way as the standard way. And this allows us to go and look at different databases. So I thought I'd just, on the last slide, talk about what does a failure analysis look like and where does this fit in. So this is a life cycle curve, typical asset life cycle curve. So on the left, you've got resistance to failure, which is high when it's first installed. And it has three distinct parts to its life. It's got the early life, which the honeymoon period, so to speak, which you know is a defects period, and generally for 2 or 3 years after the project's over and the defects period's over, things run nicely and nothing really goes wrong. And then you have what you call a potential failure point. And that's the point when things start to fail. And that's the midlife. And as you progress into midlife, the number of failures increases. Whether it's an asset or a human, it's the same thing happens, I guess. And you get to what they call the functional failure point. And the idea of life cycle analysis is to predict the life of the asset and to identify that functional failure point before the asset expires. We're trying to be proactive, not reactive. The reactive approach is the asset fails and then we scramble to replace it. Whereas if you go for the 55,000, ISO 55,000 approach, you're supposed to be proactive and trying to look after your assets and predict their failure. So what you're seeing there is an increased number of failures on that asset as you approach the functional failure point. So what I've got here is an extract from the AG Coombs service database, and it's a number of service calls on fan call units over time. And you can see this increase in failure points starts to show up as spikes in the number of calls. So then if we grab a spike and we go and look and say, well, what's this spike? And we can find we've got a particular fan call unit someone's complained about. It's hot in there, etc. And what you would normally do is you'd call up an asset record, and that would give you the information. And that's described as the location ceiling mounted above the stage, and it's a room air conditioning unit. So it's not really describing it properly at all. But that's what they've done when they've assembled the database. But we've got a VBIS code in there. And from the VBIS code, we can normalise that description. And so its correct description is a mechanical fan call unit, ducted, and it's a cooling type. And so from that, we can take the code and then we can start the search. So whether we go into iHub or your own database or other databases, say, here's the code, what do we know about these fan call units? What does their service history show? And then you can go down the path of looking at service history, breakdowns, manufacturers, models. Is it an environment issue? Is it a manufacturer, particular product manufacturer seems to fail earlier than others? And so on. So that's how you turn these codes into something meaningful, particularly if you go and hit the iHub database, and you can really start to look at different records and get some idea of history and life of those assets. Generally, from an asset point of view, people are looking to predict asset expenditure for replacement and capital expenditure for replacement. They're trying to flatten those curves into the future, and this is part of the exercise to provide that analysis of equipment life and when it's likely to fail, and what can you do about it. Can I increase my maintenance to stretch this out and make it last a bit longer? Do I, for example, if I'm going to replace a fan coil unit, where else are they? Do I take advantage of that and replace several at the same time? So they're all questions that come into capital replacement analysis. So that's all from me at the moment. At this point, we might flick over to a Q&A session and see who's got questions.
Thanks so much, Carl. That was very clear, and it will be great to see that integration of VBIS and the BRIC. I presume that will be a world-first instantiation in software of the two ontologies sort of coming together. So that's fantastic. And I kind of got to ask the question. It's a question to both of you, but for your own respective sort of scenarios. How do you build the case? The case for an IoT platform, Parag, or the case for asset mapping in general, Carl, and how do you put a dollar value on the business case for IoT platforms and the VBIS asset mapping?
I describe it, I call it the Honeywell problem. Honeywell have got Honeywell Total Asset Management, their FM group, have managed something like 25 PPPs, and they can't compare their asset databases between the sites. So if you look at the PPP issue, where they've got a fixed price essentially to maintain the asset for 25 years and hand it over in good condition at the end, they're totally cost-driven when it comes to analysing asset performance and particularly trying to predict failure and prevent failure of those assets. So if they have an asset failure, the very first question is, where else have we got these on this site? And the second question is, where else have we got these in our portfolio? And that is the key to having standard structures, standard way to referencing them. It's almost exactly what iHub's about. How do you track these things down? The next question is then, well, now I've found them all. Well, now I can go through and start to look at records and see, why are things failing? Is it something to do with where it's installed, how it's used? Is it been given a hard time? Is a particular manufacturer? All these sorts of issues you can start to do as your analysis.
So I hear you on a qualitative basis. On a actual sort of a dollars basis, is there a way that you've seen companies actually quantify that dollar value?
Yes, there are some standard sort of accounting and statistical techniques you can use to do that sort of analysis. And actually, we did part of that as part of our initial submissions to government to show how the savings could be realised on that. And you actually don't need much of a saving to generate a benefit, and particularly when you get in PPPs, and if they're critical facilities like the Victoria Cancer Centre, where the cost of having equipment down, the penalties applied under contract are huge.
Yep.
It's predictive in some ways, because to get the true comparison, you'd have to run two sites identical and have the same failure and
yes,
do an analysis on one and nothing on the other and see what happened. But when they look at the cost of particularly the penalties that apply when particularly sensitive labs and those sort of things go down, it doesn't take too much to work out. You spend a little bit of money spent up front saves you a lot of money in the long run.
Yeah, cool. And passing to you, Parag, same question. How did you get the business case going for IoT platforms?
There's a few things we look at. So first of all, we have business continuity issues from a government perspective. So a lot of our tenants, transport, health, as you know, in COVID, they are running 24/7 operations. So failures, as Carl said, are not acceptable. There's also the outgoing aspect of it. So we looked at, say, there's the BMS sites, there's sites which have mid-level control, and there's sites that have no control. So how do we pick sites for smart building IoT implementation? So that's the question. So it's sort of the mid-tier assets where BMS is too expensive based on asset location, valuation, outgoings. The two small assets are pretty much, say, 1,000 square meter spaces where a couple of switches can be flicked. We are looking at targeting the assets in the middle where they're still multi-story building, complex enough. They're aged. So as Carl was showing his graph, most of our 60% of our portfolio will be in that mid-age, end-of-life cycle status. A lot of faults. So we're looking at the operating cost, utility outgoings, and pretty much analyzing the investment per site that's reasonable in terms of how many sensors we install or all sorts of data layers and platform services we onboard on. And would the saving, doing all these things, be twice as much as the investment? and plus justify if we wanted to sell the asset, somebody is willing to pay for that high performance in terms of valuation and asset uplift. But also looking at the cap rates. If the outgoings are low, again, that will impact the valuation. Plus we are resource poor. So we want to automate as much as possible, centrally managed from head office. So we look into resourcing cost as well. So if we didn't do the IoT project, how much additional staffing would we require to deliver the same outcome? And then we have to balance. So the way Treasury looks at funding is, if they give us CapEx, they'll reduce an equal amount of OpEx. Like if it's a 5-year payback project, for example, and you propose that there's a 20% return on investment, they'll drop our OpEx for the same assets next year by a similar amount. So we have to balance on all those things. But it's looking good at this stage. Because as I said, there's absolutely no visibility before on these assets. Now we are starting to get visibility. We are finding issues and reducing cost.
So do you have a payback or a cost to benefit to cost ratio that you've been working on?
Yeah, so typically most of our projects are 3 to 7 year payback, in that range. And you never know with these IoT systems, which especially on the utility side of things, if there's one failure, which either runs the plant 24/7. So we had a case study, a 2 weeks period of runtime, and identifying it through the platform and fixing it quicker was almost like a 6 months payback for the investment made there. So it depends. You get some of these big ticket wins, but on an average, 3 to 7 years.
Cool. And so Parag, well, I've got you there. Have you come across Wired Score, sort of
Yes.
the rating system for smart buildings or digital ready status? Do you see value in trying to push for a Wired Score rating for the to assess the state, or are you really about going directly to the value-added services like the fault detection and the performance analysis?
So at this stage, we are focusing on the outcome, areas of outcome, fault detection, analytics, insights, and decision-making for CapEx, OpEx. But we have been speaking to WiredScore almost since they first signed up with Lendlease in Australia. And there's 2 aspects to our business. We get new assets like the 4-parameter square precinct developed with private sector partners. So in that aspect, our role is we set up the design brief and EOI to markets, and then landlords or property owners bid for those projects, and then we get them developed and occupied. So we are focusing on WiredScore partnership in that area, where it's going to be new design brief and fit out briefs, because it's all about the infrastructure and enablement services rather than the outcomes. Whereas they have a new tool called SmartScore. So that's another certification they have come up with recently. I hope that has been based on our discussions for 3 years. So that's going to benchmark how a building performs smartly. So that's more outcome driven rather than what goes into a building, which is about WiredScore. Like WiredScore is looking at your IT systems, your redundancies on IT systems, like cables, 2 data cables coming into the building, all sorts of things. But that necessarily doesn't give you the outcome or the productivity uplift. Whereas the SmartScore looks at how do these systems then enable smartness in the asset, which reflects into the outputs like staff productivity or business revenue generation. So that will be more applied to our existing assets.
Yep. So Gareth asks, is there a shift in New South Wales government leasing strategy towards higher performing, lower cost, greener buildings?
So New South Wales government was the first government in Australia in 2004 to introduce green leases. And also most people, this is an ongoing debate I have with the industry. Most people are aware with the Commonwealth Green Lease Framework or the EEGO Act. And again, the Commonwealth only purely focuses on energy. So when we have interactions with landlords, they come up with this green lease document, which is only energy focused. The New South Wales government focuses on 8 broad areas like energy, water, waste is your standard stuff, but occupant comfort and those sort of things. We have a 10-page schedule that goes into every lease. And recently we have introduced Green Star performance targets in that. So our current targets, and because we lease assets across the state, so it's very easy. If we had to lease Barangaroo, ask the top ratings from them, because people are paying $3,200 rent per square meter. What the market needs to understand is the government has put a strategic cap on our rent. So our average rent is about $520 per square meter across the board, 1 million square meters. So some sites will pay high, say in the metro Parramatta regions, but if we go to Dubbo, for example, it will be lower. So it's taxpayer money, so we have to be mindful of that. So we have a 5-star neighbors target without green power, 4-star water, and water is getting more and more difficult since people have introduced end-of-trip facilities and all sorts of things, which bumps up your green star score but has a negative impact on your neighbor's water rating. So 4 is a bit difficult to get into multi-story building, and 5-star green star performance, design as built, and interiors is our green star target for all projects.
Cool.
And that's above 4,000 square meters. Just to clarify, it's above 4,000 square meters because below that, the effort of people, time, and cost is not worth it based on our own studies.
Yep. Cool. Thanks, Parag. I see that we're a little bit compressed for time, but I'll keep going because I think there's valuable discussion to be had here. Carl, does VBIS only cover engineering services, or is it wider than that?
It's much wider than that. We've got about 23 categories we've done at the moment. So that covers pretty well everything inside a building and outside the building. So it's all the services, furniture fit out, the structure itself, landscape, and so on. We've also got ongoing discussions with some of the transport departments and road, rail, etc. And it's probably early stage, or it's not early stage, we've been discussing it for a while, but they're certainly looking at the same sort of thing to categorise that equipment, and also in-ground infrastructure to extend the services out to everything in the ground. So it doesn't really have a limit. It's really it's more a matter of getting the people with the right people with the right knowledge to then apply it to those areas.
Cool. Thanks, Carl. So, Carl, the value of standards is often where everyone adopts them. And so, in your case with VBIS, does everyone have to adopt VBIS for VBIS to get to be valuable? Or can it be sort of used standalone and quickly and easily?
It can be used standalone. There's 2 parts to VBIS, and one I didn't talk about, which is the syntax to communicate. That syntax is a syntax to communicate via browser URL and pass parameters. It's essentially a search and display request to an application. So it means that the links won't break, they don't become redundant. Even if you move to another platform, it's a domain name swap. You're not really modifying the link instructions and so on. So that's that side of it, and that's got nothing to do with the coding. You can pass anything with that syntax. And then with the coding itself, you can adopt it in part or full. It really depends which part of your asset databases you want to start analysing. And it may be that you may focus on, say, mechanical or electrical in the first instance and pick up the balance later. And the other side of that is that some of the vendors, so the FM software vendors, so there's quite a shift into software for service. So you've got quite a few vendors offering FM applications in the cloud, and they're picking up VBIS as the standard way to classify assets within their systems. That has a lot of advantage. A lot of clients don't really know how they want to structure it. And it also allows them to start expanding their services to allow a client to compare their assets to other assets, even though it may be anonymously within that vendor's software database and so on. And then the other side of that is it then allows companies such as an AG Coombs or Spotlight or any of those who have large asset portfolios on record to start to offer that as a service out to allow IHAB to come into that and collect information and compare IHAB records with what those portfolios have and so on. So it will evolve.
And you sort of touched earlier on, you said VBIS is not software, but then I think you started to talk to VBIS being sort of substantiated inside software. So what are the kind of use cases people creating software that inherently utilizes VBIS? What are you seeing out there in the market?
We're seeing quite a bit of adoption. One of the demonstrations we set up was Matterport. So Matterport allows you, I call it Google Street View for the inside of a building. So you can take your 3D photographs of the building, plant rooms, for example, stitch them together in Matterport and create an environment where you can walk around the plant room and look around in 360 degree. Now within Matterport, you can take any object that's photographed in that plant, such as a pump, for example, and you can apply links to it. So our demonstration, there's a little video on the VBIS website where you can see that I can click on that pump and it might call up a drawing or something from an O&M manual. Now that's using the VBIS syntax to talk to that application. In essence, what we're doing in those situations is we're populating the search screen of that application and pressing the search button and giving a result. That's really what it's doing. And so we're starting to see a lot of people take interest in that. It's nice to be able to look around a plant. It's even better if I can tag everything in that 3D view and then actually interact back to my equipment. And the other part of that is that you can then leave the application and go back and zoom into that 3D photo to show you where that asset is. So, you know, a lot of people talk about the 3D model and animating the model, but I think most people would relate to the photographic 3D view more than the trying to stumble away around a BIM model. They all have their applications. BIM's more likely to be, I think, a virtual reality overlay. So you can go into that 3D photograph and then say, well, what's above that ceiling I can see there? And that's where you can start to superimpose the BIM model and see what's above the ceiling from a modelling point of view.
That's awesome, and that sort of segues actually into a question I had for Parag, which is the human dimension of implementing technology. Notoriously we sort of put these smart systems in and then no one uses them. What are you doing to engage facilities managers and contractors to actually use the IoT capability that you're creating?
So we have been running a lot of platforms for almost 3.5 years. Things like Buildings Alive, GreenSense, EMC, there's almost 8. And in the first year, what we did is we did pilots. So we implemented 2 or 3 different platforms. There was a survey set up with the FMs. So likes, dislikes, where things can improve, from information provision to them for quick action. So you don't, because as I said, we have remote management of sites. So one FM would be looking after 60 properties or 50 properties. So they don't have enough time in the day to dwell into technical details of each site or walk up and down the plant room. So that had a really good outcome. So what we have done is targeted email-based feedback. So no logins. That was the thing we came up with. So nobody has to create passwords and things. The information directly comes into the email. So if you are a senior manager, you have, say, 10 properties, you'll get a summarized email on asset performance on a daily basis on how they're performing. At a site level, if you are looking for a site-specific information set and issues, you get an email for that specific site and all the aspects that have been monitored, and gives a summary of, if the email tag says all good, you don't even look at the email. So that's one of the options. We also have set up for more detailed investigation actions monthly meetings. So our internal team does reviews of those issues which are big ticket priority items, like which cost more or have been going on for some time. And they themselves go to site and then investigate and form a view, and then work with the building manager and the contractor to develop an action plan. Also, all our communication is set up to go to 3 parties. So the sustainability team, the in-house FM contract team, the JLL FM, and the contractor at the same time. So there's pretty much most time people just spend on forwarding emails and making phone calls. So we want to send the information exactly at the same time to all relevant parties for action. And what the 3 people out of the 4 are waiting on is just the contractor's feedback and close out of that item, if it's a straightforward item, 70% of the time. So it's been working pretty well. And that's how, with the support of the broader team, we have improved the portfolio from 2.5-ish star rating assets to almost close to 5-star.
Yeah, that's awesome. Good insight. So we're 10 minutes over time, but last comments. Carl, do you want to give any sort of final comments, anything that we missed in that discussion?
No, I just think it's a great initiative, and the more people get on board and realise the value of it, the better. You know, I know from within Coombs themselves, but if you're looking at this purely from a business perspective and what can I get out of it as a business, it's easier to farm than it is to hunt. It's as simple as that. So and that's a standard sales knowledge. So if you can find a failure on a piece of equipment, you can say, well, wow, where else have we got these? I'm just looking at this purely as a mercenary point of view. Who else has got this problem? And I can go and approach them, and maybe we can help them and get a win-win for everybody. So, you know, and this is the only way you're going to do it, is to have these sort of facilities that you can start to compare and start to really see where do I have similar problems, or where do I have some similar successes. The converse is true as well. If I've got a piece of equipment that's been going for 30 years, well, where else have I got those? And is that my experience or someone else's experience? And that can teach you just as much as the one that's failing.
Beautiful quote. I'll take that one away. Parag, last comments?
Yeah, I'm looking forward to an industry where everything is open source and no proprietary systems. Also, anonymized data sharing. As Carl said, like if we have more data on the platform, we have like 1 million buildings, and we can check across all buildings what things are going wrong, and single point of failure, all sorts of research stuff. That would be great. And also everybody participating in these sort of initiatives and the industry going to wireless smart building setups would reduce cost of software applications and technology for everyone. So as I said, like it should be like the subscription services. So you have more people on Netflix, it's cheaper for everyone. So that's Beautiful. What I think should happen in the future.
Thanks, Parag. Thanks, Carl. You guys have been brilliant speakers. Thanks, Marie, for setting things up, and thanks for all the iHub crew. And we'll see you tomorrow at the next iHub seminar on living laboratories. Thanks.
Cheers.
Thanks a lot.
Thank you, everyone. And just to echo what Stephen just said, a special thanks to our presenters today, Carl, Stephen and Parag, for delivering such a great session and providing us with all your insights and knowledge. A special thanks to everyone who registered and also attended today's session. And as Stephen just mentioned, we do have the last session on tomorrow on Living Labs at the same time, and we would love to have you join us once again.